Hello learners, welcome to the next session in quantum computing. In this session, we are going to discuss about quantum generative adversarial networks. So the session outline is quantum generative adversarial networks, quantum generator and key features, and what are the different kind of approaches are there, and structure of Q generative adversarial networks. So, as per the definition, quantum generative adversarial networks are quantum enhanced version of classical generative adversarial networks. So, quantum computing principle in that we can go with the superposition and entanglement to address the limitation of classical adversarial networks such as computational inefficiency and difficulty in modeling complex data distributions. Qgen consists of two components, a quantum generator, a quantum discriminator, with interact adversarial to produce high syntactic. Quantum generator is the key component responsible for generating syntactic quantum states that approximately the probability distribution of the real-time data. So here we are going to discuss about quantum generator class in Qiskit along with its role of Qgen and with example application. Key feature of Qgen. Here we are going to discuss about the parameterized quantum circuit. The generator is implemented as a quantum circuit with the tunable parameters. These parameters are optimized during training to minimize the difference between generated and real-time data distributions. Next is the training process. At the start, the generator's parameters are initialized randomly, producing random outputs. Over multiple iteration, it learns to generate quantum states that closely related to the target distribution. And in the case of applications, we can directly go with trained generator can be used for tasks like state preparation in quantum amplitude estimation. It's also called as QAE or generating syntactic data set. When we are going to discuss about the parameters, the first parameter is bounds, defines the range of data values. Next, num qubits specifies the number of qubits used to represent each dimension of the data. Generator circuit, a custom quantum circuit for generator. It may be optional. Next is optimizer, optimizes the generator's parameter during training. Next is gradient function, computes gradients for parameter optimization. Next is the structure of Qgen. So it is about the Gaussian noise is also there, ket z and generated ket lambda. Both are to be applied in the discriminator, and we are also passing the real-time data. So with that discriminator, we can easily predict whether it may be a real data or fake data. So ket real or ket fake. So it is also represented as R of ket lambda equals rho sub lambda to the R. So in the case of interpretation, ket lambda, a classical quantum input, a label or it may be a latent variable, or a quantum generator, possibly a parameterized quantum circuit or quantum channel, rho lambda or the quantum state output by the generator are conditioned on the input ket lambda. Meaning of that Qgen, this equation represents the generator's output. The generator R takes an input ket lambda and produces the quantum state rho lambda R. This output state is then used in training, typically being compared to the real quantum data set by a discriminator. The generator wants to generate a similar sample to the real data set. The quantum states perform that by variational quantum circuits VQC that are constructed by gates and parameterized vector theta g. The generator receives two quantum states as input. One of them is the label of ket lambda and other is the Gaussian noise ket z. To create the following quantum state, we can go with this kind of equation: g of theta g comma ket lambda z, which is equal to rho lambda of g theta g comma z, which is equal to determinant of psi lambda ket z and bra psi lambda of z. So here we can easily represent all kind of lambda and ket z as a output is similar to the real world discriminator. It is also useful to know that first the discriminator attempts to develop its approach to discriminate between real data and fake data. Then through the feedback from the discriminator, the generator will output to get the better results. How does this Qgen to be work? Input data encoding, adversarial training and convergence. In the case of input data encoding, real data is encoded into quantum states using techniques like amplitude encoding. The generator produces synthetic quantum states based on the current parameters. The next is adversarial training. The discriminator evaluates whether the generated states match the real data distribution. The feedback from the discriminator guides up the generator parameters via gradient based optimization. So in the case of convergence, the generator learns to produce quantum states that are indistinguishable from the real world data. So here we can easily match this QGen with the help of Benny LAN. So Benny LAN helps you to build and train quantum circuits just like you go do with neural networks in PyTorch or TensorFlow, and even combined with the classical models. So here we are added some of the packages and we are going to define the quantum device and quantum generator also to be introduced with the help of generator underscore circuit and wait. Next, discriminator is also there. So here we are going to check with the classical neural network with the linear and different kind of sigmoid functions, and we are going to initialize the weights, and optimizer is also to be introduced with the weight and parameters. And the next thing we are going to check with the training data of torch.tensor values to be passed, and different kind of approach values to also to be applied, and generate the fake data, and train the discriminator with the help of different kind of metrics, and train the generator. Finally we can easily get how the data to be differentiated between the fake data and original data. So these are the different results we can get in the generator loss function and discriminator loss function with the help of a value. So finally we will reach the data to be easily classified into two different thing as fake data and real time data. So thank you learners. We will see in the next session.